Let's talk about scientific notation. Scientific notation is useful for two main things. One thing that scientific notation is useful for is writing very, very big numbers in a small, compact space. And the other thing it's really useful for is writing really, really small numbers in a tiny space. And scientific notation is all based on writing numbers multiplied by powers of 10. So let me show you what I'm talking about with this first example. It says the distance from Earth to the Sun is about 93 million. That should say 93 million miles. Let's put a unit on there. Write this number in scientific notation. So anytime you write scientific notation, you write your big number times 10 to some power. So our number here is 93 million, and what we're going to start off by doing is look just at the numbers that aren't zeros. So the numbers we have here that aren't zeros are the 93 right there at the beginning. So that's going to be the first part of our scientific notation is the 93. And now we are going to put a decimal in this number so that the number is between 1 and 10. And that's important. We're going to put a decimal here so that the number's between 1 and 10. Where could we put a decimal in 93 so that it's between 1 and 10? The obvious answer is between the 9 and the 3. In between 9 and 3, we get 9.3, and 9.3 is between 1 and 10. Great. Now, obviously, 9.3 is not the same thing as 93 million. So here's where the rest of scientific notation comes in. We're going to take that 9.3 and we're going to multiply it by 10 raised to some power. And whatever the power is, it needs to be something that turns 9.3 into 93 million. And the way that we figure out what the power should be is just by counting. So let's go in and zoom in real close on our 93 million number. If we put this decimal right here, right in between the 9 and the 3, which is where we put it, how many times would we have to move the decimal to get to the end of this number? The end of this number is right here where the period is. How many spaces would we have to move that number? Now, the reason we're counting spaces is because when you multiply by 10, that's all that happens, is that you move the decimal over one spot. Multiplying by 10 just adds a 0 to the end. For example, 7 times 10 is just 70. We just add a 0 to the end. 70 times 10, we just add another 0 to the end. It's 700. So when you multiply by 10, you're just adding a 0 to the end, which is the same thing as just moving the decimal over a spot. So how many times do we multiply by 10 to turn 9.3 into 93 million? So let's count. So there's one spot that we'd move the decimal to move it from 9.3 to 93. That's moving the decimal one time. So that's multiplying by 10 once. If we move it again, this is multiplying by 10 two times. That would give us 930 if we move the decimal there. If we move the decimal again, that's moving the decimal three times. That would give us 9,300, and so on. So let's just count how many times do we have to move it to get all the way to the end of this number. So we've already gone 3 times so far. This is 4, 5, 6, 7. So we move the decimal 7 times to get from 9.3 to 93 million. So the answer is 9.3 times 10 to the 7th power, and that is that number written in scientific notation, 9.3 times 10 to the 7th power. And if we put 9.3 times 10 to the 7th in a calculator, we would get 93 million. Let's do a few more examples. Let's take a look at this number, 6,400. So just like on the last one, we're going to look at first only at the numbers in front of all the zeros. And in this case, it's a 64. So we're going to start with 64. And we're going to place the decimal somewhere so that the number we get is between 1 and 10. Obviously, we're going to put it in between the 6 and the 4 to get 6.4. That's our number, 6.4. It's between 1 and 10. So if we look at our original number, 6,400, if we put the decimal in between the 6 and the 4, how many times would we have to move the decimal to get to the end of the number 6,400? Whatever that number of times we move it is, that's the power that we're going to raise 10 to. That's how many times we would have to multiply by 10. So we can move it 1, 2, 3 times. We have to move the decimal 3 times to get to the end of that number. That means we're going to do 6.4 times 10 to the third power. And there it is in scientific notation, 6.4 times 10 to the third power. Okay, here's a really huge number. This number is actually read as 570 billion. This is a really giant number. So scientific notation is really useful here for taking all these zeros and compacting it down into a small space. So we're going to look at the numbers before all of the zeros, and that is the 57. We put the decimal in a spot that will make the number between 1 and 10, and that's going to be in between the 5 and the 7. And then we're going to multiply by 10 raised to some power, and we're going to have to move the decimal a lot of times to get to the end of 570 billion. So if the decimal were right here, let me make my pen a little narrower here. We move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times is how many times we have to move that decimal point to get to the end of that number, 570 billion. So this is going to be 5.7 times 10 to the 11th power, and that's that number in scientific notation. Okay, let's do one more example. Let's talk about a light year. A light year is the distance light travels in a year, and it's equivalent to, this is a gigantic number, 9,461 billion kilometers. And we're going to write this number in scientific notation. So let's look at the numbers in front of all the zeros. And this time we've got 4 of them. 9, 4, 6, 1. Those are our numbers we have in front of that big long string of zeros. So we're going to put the decimal in a spot that makes this number somewhere in between 1 and 10. And maybe you've noticed that the decimal always goes after that first digit. 9.461 is between 1 and 10. Funny how that works out. It always goes after the first number there. So that it's between 1 and 10. And we're going to multiply this by 10 to some power. Let's see what the power is going to be. It's going to be a huge one because we have to move the decimal a lot of times. If we started between the 9 and the 4, how many times would we have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times we would have to move the decimal, or 12 times we multiply by 10 to get from 9.461 to 9,461 billion. So the speed of light, or the distance light travels in a year, written in scientific notation, is 9.461 times 10 to the 12th power.